Here we have an example of a BD controller 3.8. In testing a BD controller with a gain of 1.0 and a derivative time of 2 minutes, an error signal as shown below is applied. Calculate and describe how the controller output will respond with time and sketch a response. Show your calculation. So here we have the gain of 1.0 and we have the derivative time of 2 minutes. The graph here shows the error signal. The x-axis has shown the time in minutes, while the y-axis showing the error in percentage. The main point here is to find how many intervals do we have. So in this graph we have 3 intervals. Number 1, from 0 to 2. The time here is from, or t is greater than or equal to 0 and less than or equal to 2. This is number 1. Number 2, when t is greater than or equal to and less than or equal to 6. So this is the number 2 interval. The third one is when the t is greater than 6 minutes. Please pay attention to these intervals and try to find them accurately, because we're gonna use them later on sketching the output of the controller. For interval number 1, when 0, so again number 1, when t is greater than or equal to 0 and less than or equal to 2 minutes, we are talking about this interval. Just to remind you that gain is equal to 1 and the error at this situation or this case is equals to 5%, as shown in the figure here. So the technique here is, first we have to find the controller output M for the proportional controller in the first, and second we're gonna find the controller output for the derivative, and finally we're gonna add these two outputs. So here, number 1, the controller output due to the proportional action, we're gonna call it MP. So MP equals to the controller gain, or the gain of the controller, multiplied by the error, as you have remember in the proportional controller. So here the gain is 1 and the error is 5, so 1 multiplied by 5 equals to 5%. Second is to find the controller output due to the derivative action. MD, this is very important. Those equations to find the output of the controller based on the type is very important, and you have to always remember them. So MD equals to KC, which is the gain and derivative time, multiplied by the dE over dt, the differentiation of the error with respect to the time. So KC, which is the gain, is 1 multiplied by the TD, which is 5%, okay, multiplied by the dE over dt. So here the dE over dt, as you see here, there is no change in the error. So there is no change in the error with respect to the time. It's constant. So dE over dt equals to 0, which is then finally the MD equals to 0. sorry, here is 2% again, so 1 multiplied 2, TD is 2%, which is this one, sorry, 2 minutes. 2 minutes multiplied by 0, there's no change, equals to 0. Now for the third section is to find the total output of the BD controller. MBD equals to MB plus MD. The MB is already here is 5%, okay, plus MD, which is 0%, equals to 5%. So now it's clear that the output of the controller due to the proportional derivative equals to 5%. So we started from time 0 to 2 minutes. So we have finished from this interval. The first step here is to find the equation of the straight line of the error line here from 2 minutes to 6 minutes. It's a straight line, so as you remember that we have the straight line equation with the 2 points here, x1, y1 and x2, y2. x1 is 5%, y1, while the x2 is 6, and y2 equals to 25. Straight line equation, as you remember, y minus y1, y2 minus y1 equals to x minus x1 over x2 minus x1. So y minus 5 over 25 minus 5, which is y1, equals to x minus x1, which is 2 over x2, 6 minus 2. So 4 multiplied minus y minus 5 equals to 20 multiplied by x minus 2. Then you will find that y equals to 5x minus 5, and this is the equation of the line. So if you'd like to express it with respect to the ET equals to 5t minus 5, and this will be in percentage. So the ET equals to, again, 5t minus 5, because the x-axis is time. It is the time in minutes, minus 5, that's in percentage. So due to the proportional, we can calculate the MB, as you remember that MB equals 2kc multiply the error. So here kc is 1, the error is 5t minus 5, so you have it 5t minus 5 percentage. Remember that we are working on this interval. Second is to find the MD, the derivative, the output of the controller due to the derivative mode. MD equals to Kc, time domain or time of the derivative, multiplied by the dE over dt. The Kc is 1 multiply the time domain. So here the gain is 1, TD from the question equals to 2 minutes multiplied by the derivative of the error equation, which is the d over 5 t minus 5 over dt. So here, as you remember, the derivative of 5t with respect to delta dt equals to 5, and the derivative of minus 5 equals to 0. So here it will be 2 multiplied by 5 equals to 10%. The third part is find the total, the MBD, which equals to the MB plus MD. So here we have 5t minus 5 plus 10 in percentage equals to 5t plus 5%. And then we can substitute for M2 equals to 2 multiplied by 5 plus 5, which equals to 15%. Again, we have 5 multiplied 2 plus 5. And then we have, this is 0.2 or 2 minutes. For 0.6 here, we have M6. So 5 multiplied 6, 30 plus 5 is 35. So now we come to the drawing. This part is we are done from this part. So this is already step 1. Now we are here. So as we have said, that this is 2 minutes. We got 15% if we have 2 minutes. So the output of the controller at 2 minutes, or at 2 t equals to 2, while at when t equals to 6, the output will be 35. So we have this line, okay, and because these 2 points are the same, so we have to connect them in 1 point. The third interval is when t is greater than or equal to t. So we are talking about this interval, and we can see it's clear from the graph that at when time or t equals to 6, then the et equals to 25%. So here we have t equals to 6 and the et equals to 25%. So the MB, the output of the controller due to the proportional mode, equals to, as you know, Kc multiplied by E equals to 1 multiplied by 25 equals to 25%. The output of the controller due to the derivative equals to Kc and multiplied by Td multiplied by dE over dt. So it's equal to 1 multiplied by 2 multiplied by dE over dt. The change here in this part, as you can see, it's, so we are focusing now on this part. So the dE over dt, the rate of change of the error in this part is 0. So dE over dt equal to 0 in this part. So we have dE over dt equal to 0, then md equal to 0%. So as a total, the mpd equals to mp plus md, which is 25 plus 0 equals to 25%. So the output of the controller due to the proportional derivative control mode equals to 25% if the t is greater than or equal to 6 minutes. So we are in this part again. This part is due to the interval 1, which is from 0 to 2 minutes, and then we have number 2, interval from 2 minutes, okay, to 6 minutes. So this is the part of the output, and then finally we have if t is equals to or greater than 6 minutes. As you can see, here is the 25%. This is the MT, or so this is MT or MBD, okay. And each point or each output in the same time point, we have to connect these 2 points if they exist in the same time point. So now we have this graph represented the response of the controller or the output of the controller due to the proportional derivative with respect to the change of the error, which seen in this example.